Welcome back to Building HVAC Science. I have three guests on the show today, and this is going to be a joint video audio. So are you listening on the audio, you want to go take a look at the video. It'll be on the True Tech YouTube channel. If you want to see the reaction on these gentlemen's faces, I do call them gentlemen with a little tongue in my cheek. We have Clifton Beck, Eugene Silberstein, and Jason Obrzut.
Very
How
good.
did I do, Jason?
Yeah, really good.
Mm-hmm.
Okay, thank you.
Better than my first attempt.
So these gentlemen all work for ESCO, and I'm going to first ask Clifton to give his background, but also talk just a little bit about ESCO since he's the newest one with ESCO. Go ahead, Cliff.
Thank you so much, Bill. Yeah, glad to be here. Yeah, I started my career. I married into a HVAC business. So I started really early in life and realized it was a good income. And so I was the little guy. I was the, crawl space and attic guy. And I loved controls and technology. So I real quickly got into service and got into new controls, got into refrigeration, got into commercial industrial refrigeration, got into building automations. Went back to school, grabbed a master electrician license, got into designing and controlling automation controls, and thought that that's where I would just stay because that was a really lucrative place to be. And I got recruited into training about 6 years ago by just a wonderful gentleman that called and said, "I think you missed the bar." So then I got into distributor training, and I got into distributor training because of the changes that were happening in the residential equipment. So all of the things that, that I was customary to in the commercial industrial side was happening in the residential. So it was a great opportunity to be able to take what I knew and just implement it into a different style of equipment and reach a broader scope. And I have been working with ESCO the entire time.
Oh.
So yeah, my entire educational side has been hand in hand working with Renee and Howard, and just spent a lot of time knowing what ESCO was doing. And so we've had a lot of conversations in the last few years. So as the SEER 2 changes and as the A2L changes were happening, we'd had some good conversations. And I thought, man, what a wonderful opportunity to be on the front side of the kind of changes that I seen when I first got into the industry. Mm-hmm. Because I was in that CFC phase out, and where, like we've talked so many times, where we had a lot of refrigerants on our van, and we got to see that side. So it's just filling in another blank in the industry, doing what I can do to bring my experiences and help educate some of our younger generations and share some of the things that I've learned about training along the way, and just be a part of a great, big, beautiful painting that's being painted about our industry right now. And I think ESCO is right at the heart of that.
And ESCO is, for the listeners who don't know?
ESCO Institute in HVAC Excellence is the leading educational organization in our industry. A lot of people don't realize when you go to post-secondary and trade schools that, that is the curriculum, a lot of the curriculum that you're working with. And so as we continue these conversations with like Eugene and Jason, we're now talking to the authors of a lot of the books that are being used in our publications. So I bring the technician side and just help add that little extra character for the new equipment that's changing. And then HVAC Excellence is, of course, the body of ESCO that is looking at a third-party evaluation of the curriculum and the design of the HVAC programs in our post-secondary and vocational and high school, and hopefully start growing down lower as our industry starts promoting the trades in younger ages.
And your role now is in education for ESCO, your new role?
My role is manager of digital media. So it is a lot of, organizing and building our media collection. I think we're up to about 22,000 components in my media inventory right now of things that ESCO has built throughout the years. And so we're re-archiving that so we have easy utilization of that for all of our content creators, because we have a lot of internal content creators like Eugene and Jason and myself, and we have other members that build other curriculum. So trying to streamline where our content is at so that we can help build content faster as we see a lot of big changes coming to our industry in these next couple of years. So that is that is my current role. And I'm like you and like everyone in the industry, you are where you are at the moment
Right. Right.
because it
Things always
changes
change.
so fluidly.
And you're based out of Indiana, is that correct?
Yeah, I'm just outside of Indianapolis.
Gotcha. All right. Moving on to Eugene. Give us some background.
I will. Yeah, actually, Clifton said he married into HVAC, and I was born into HVAC. My father was an HVAC guy from way back when, and I started in the industry in 1980. So we're closing in on 43 years
Nice.
in this industry. And yeah, I worked with family owned businesses. We had the opportunity to own and run three service companies, primarily Midtown Manhattan. We did a lot of the high rise equipment. And as years go by, family issues, and say, you know what, I don't think I should be working for a family anymore. So I actually answered an ad. We actually is an ad. It was actually in a newspaper. I don't know if a lot of people are aware that there were actually newspapers at one point. And I actually answered an ad for a service technician. And I answered, the ad showed up for the interview, and it was at a trade school in New York City. And I walked in and I said, I think I'm in the wrong place. Why would a trade school be looking for a technician? And in actuality, they weren't. They were looking for teachers. And I was a little upset with the director when we were sitting down at the table. And he was like, well, if I put an ad out for teachers, would you have answered it? And I said, absolutely not. Because I'm somebody who at that time hated everything about the educational process. I hated school, hated books, hated reading, hated writing, hated everything about education. And the director of the school convinced me to join his staff and help me get my state teaching license. And then before you knew it, I realized I could actually teach. And the textbook we were using at the time was riddled with technical errors, and you might have heard it. It was Cengage Learning's refrigeration and air conditioning technology. And shortly after I started teaching, I became the chairman of the refrigeration department, and the first thing I did was pull the book out of the school. And I got
true attention, right?
I got contacted by the publisher, and we met, and we hit it off. And they said, well, what would it take to get the book back in the school? And I said, well, when the book goes to its next edition, I want to review it. Well, to make a long story just a little bit longer, I'm now the co-author of that book. Presently in its 9th edition, where Jason and I are working on the 10th edition right now. And I've been on that book, actively working on it, either behind the scenes or on the front cover since the 4th edition. So kind of interesting, but a New Yorker moving out to California, and I didn't have any job prospects. I didn't know what I was going to do when I got to California. I said, I'm going to get to California, and when I get settled, I'm going to go to schools who use my book and show up and say, here I am, hire me. And then I got a call from Jerry Weiss, our CEO. And he was like, oh, little birdie told me that you were planning a move out to California. What are your plans for work? I'm like, I don't have any. So I told him my plan about showing up at schools and having them roll out the red carpet. And he's like, you wrote, direct, and taught your own program out at a college in New York. So you realize how hard it is to get a line open for teaching. And we were chatting, and he's like, oh, we have this thing called Title 24 that we're working on. And, we don't have boots on the ground in California. We spoke 15, 20 minutes, and he offered me a position with ESCO right then and there. And before I even moved to California, I had a job. Cool. Which was actually kind of neat. And then, just like Clifton and, joining the ESCO team, I didn't realize how involved we were. So the ESCO group is really our mothership. I mean, we have the document registry now with Title 24. For those of you out there who have Section 410A certification, that's through the Air Conditioning Refrigeration Safety Coalition. That's us. The Green Mechanical Council is us. HVAC Excellence is us. So there are a bunch of other organizations that fall under the ESCO group umbrella. So I started with ESCO in September of 2015. So we're it's it's been a really, really awesome experience getting to work with so many schools, so many teachers, so many industry professionals. We certify technicians. We're the largest issuer of EPA certifications in the country. So we certify technicians, we credential instructors, we have credit programs. So it really is, it's a different task every day. We're doing something different all the time.
2 million certifications.
Yeah,
2 million. Yeah. So thank you, Eugene. Jason, if Clifton was married into it and Eugene was born into it, you were either adopted or abducted into it? Please.
I would say adopted, yes.
Okay.
I was working in a job on a dock, and we got laid off, and I went to a trade school for HVAC, and I graduated and got a job, and the guy that taught me was really, really good teacher, and he got sick a year or so later and had to take a bunch of time off, and the school reached out to me to ask me if I could come back and teach nights while working during the day. And eventually he passed away, and they asked me to be the full-time instructor. I worked my way all the way up to the director of education there in Chicago at the school. I was there for 15 years teaching while running a contracting business as well, to keep my thumb on the pulse of the industry, so to speak. And like Eugene, I got a phone call from Mr. Weiss saying, "Hey, we've seen some of the things you're doing. We've seen some of the things that you're writing. We'd like to get you on board, get you out of the teaching day class, night class, all these days a week, and start reaching out to more and more schools." Up until that point, it was just my classroom, my students, and the education, HVAC education industry outside of that, I was very unfamiliar with. And when I came on board ESCO, I was able to get into more classrooms and talk to other instructors. And I would go to the conference and see the big reach that they had. And I'm like, yes, this is for me. I'm going to do this.
Nice.
And then I was approached by Cengage and Mr. Silberstein here to help out on some titles, certain titles. And I kind of fell into that. I don't know if you want to say abducted or adopted, but I think I tripped into that one. Okay. I fell into that one.
Fell into it. Okay.
Yeah.
We'll accept that. So thank you for that wonderful background. That sort of sets the stage. Some things that are talked about here is it's an exciting time. There's rapid changes. These gentlemen bring together so many different resources from their experience, but also know how to access resources and are such a reliable source of information. And along with information goes sometimes misinformation. So we want to make the topic of this podcast is myth busting, some potential myths we could bust, things that you might have heard, things you might even believe or just are questioning about. So I'm just going to throw one of the myths out there, and then whoever wants to speak up first, get into it, and then I'm sure all three of you will add to it. So the first one is heat pumps are just for the south, installed south of the Mason-Dixon line. They will not work in the north.
Can I hop in on that one?
Sure.
as a northerner, it in the 80s, the majority of heat pumps had 2 speeds, on and off. And if a heat pump system is not properly sized, properly installed, properly charged, the system might work in the cooling mode, but it might have difficulty in the heating mode. And I always give this example because I grew up on Long Island in New York, and in the summer we're designing systems for 75-degree indoor temperature. And on Long Island, we design systems for 85-degree outdoor ambient temperature. So a heat pump system operating in the cooling mode is pushing against 10 degrees. So if the system is not properly sized, if it's not properly installed, if it's not properly charged, it'll work a little harder, but it'll still cool the system, cool the space. Well, flip over to the winter. So now we're designing for a 70-degree indoor air temp, and we were designing for a 15-degree outdoor ambient temp. So now we're looking at a 55-degree delta T between indoor and outdoor. So any deficiencies, if the system is not sized right, if the ductwork is insufficient, if it's not installed, if the system's not charged right, any deficiency that might be overcome by increased system operation time, now the system's having a harder time. So to
What a
alleviate that, yeah,
what a great way of putting it. I mean, that really drives home the point. Bigger delta T's exacerbate difficulties or deficiencies.
yeah,
Wonderful.
it's what happens is, being an educator, you're kind of trying to explain things to people in words of one syllable, the way they'll understand
Right.
it.
That's right.
Right.
So even when we're talking to the public, I've done a lot of seminars on heat pumps, and a lot of the attendees of the sessions that I was conducting were homeowners.
Mm-hmm.
And one of the major problems that homeowners had was they were complaining about the electrical use, their electric bills going up. And the contractors, because they didn't want the service calls, the nuisance calls with a heat pump, they were wiring up second stage heat with first stage heat. So now when the heat pump turns on, you're running the compressor, but you're also running the electric heat. So the electric meters are spinning 3,000 miles a second. So the mindset of heat pumps in the north was they don't work and they cost too much to operate. And unfortunately, it really points back to, if the system's properly installed, if it's properly sized, charged, they will work. And another problem is there's improper or inadequate customer education. The customers that are getting these systems installed, again, coming from New York, a lot of people, they lived in big houses and they had fossil fuel heating systems, they had oil, they had gas, and they're expecting that blast of scorching hot air coming out the supply register. Heat pumps, not so much.
Mm-hmm.
And when heat pumps go into defrost, right, we're tempering that air. So customers will call up complaining that the heat pump isn't heating, but it's blowing cold air, even though it's working correctly. So there is a big misconception that heat pumps are only for the South. But especially now with inverter technologies, we're able to ramp compressor speeds up. When we ramp the compressor speeds up, the suction pressure, the low side pressure and evaporator temperature goes down, making it easier to absorb heat from outside. And at the same time, the head pressure goes up, making the condenser temperature hotter. So we're able to effectively absorb heat into the heat pump system, even at lower temperatures. So yeah, heat pumps, have come a long way since the 70s and 80s, the single speed on and off. But yeah, it's definitely a misconception. We have people in, even northern New York, in Maine, putting in heat pump systems, and they're able to provide heat.
Yeah, I lived a couple years here in our house with a 2-ton air source heat pump. I purposely switched off the resistance. It's disconnected.
Sure.
And we survived through, -1 degree nights, things like that. We do have a really well insulated house and a pretty good thermal mass to pull off of, but I'm always looking at the thermostat and seeing, it's off by like 1 degree. That's about it. And it's slowly you're bringing it back up with those lower speeds and of the compressor with the inverter technology. I'll let someone else give some nuance to this, Jason or Clifton.
I was just going to echo Eugene's point that some of this has to do with educating the customer's expectations. They're expecting 120, 130 degree air coming out of that vent. You're just not going to get that with a heat pump. And the other thing that Eugene brought up was the delta T between the indoor and outdoors. You move into the northern climates, we have a lot larger delta T than you do in the. Does that mean they won't work? No, they will work. But as you mentioned in your house, using the heat pump, a lot of houses in the north aren't as tight as they should be.
Mm-hmm.
They're quite drafty. Again, designed that way because we're burning fossil fuels in this home and we want fresh air to come in to replace for combustion air. So when you're working in the northern part of the country and you have these colder climates and you want to go heat pump, one of the other things that you want to look at, aside of sizing it right, installing it right, is look at the structure itself. Is it conducive to a heat pump? You might do everything perfect install, perfect sizing, everything, but we have leaky duct work, or we have a drafty home and it just can't keep up. So we have that little bit of extra added step to look at the structure itself and see, will a heat pump do okay here? That's something that's a little different than we have in the South.
Yeah. Got it.
One of the things that gets overlooked so much when we talk about the changes in design is the calculations for COP. The coefficient of performance that we had in equipment that was R22 10 SEER equipment, we didn't produce the type of heat that we do now. So now we have units that are, at 47 at design temperature, we're producing COPs that are higher than ground source heat pumps. And of course, they're all going to diminish as we go lower. But, when we look at some of the earlier heat pumps, even our early inverter heat pumps, some of those were actually having cutoff temperatures at, plus 5 degrees Fahrenheit. So they were actually shutting off at 5 degrees, going 100% resistance. And so we have different layers. So helping people understand that COP has changed and those cutout temperatures have changed so drastically with the changes, like Eugene said, with a variable refrigerant control where we can change our suction and our discharge pressures. We really have three types of heat pumps. When we look at, COP design, we have some that shut off at +5, we have some that shut off at -5, and we have some that shut off at -15 or lower. So we can now produce heat pumps that, like I have a low ambient heat pump here that has got 100% capacity at -5. Pretty significant. It's about 40% at -15. So, when we're looking at heat pumps, understanding that not all heat pumps are the same is the biggest factor, because they don't fall into a characteristic. At one time we had different manufacturers producing a heat pump that had one refrigerant and it had one speed of compressor and it had one metering device, and you got the same kind of performance across the line. Now we have multiple designs, and the prices are going to increase as we go to lower temperature capabilities, but it's because the engineering has increased so much. So you can be looking at a piece of equipment that produces zero heat at -5, or you can look up the line and have one that's producing 100% heat and still producing, COPs well above 1. So much higher than using, electric resistive heat of 1-to-1 COP. So that coefficient of performance is probably the most misunderstood thing when we're talking about heat pumps and utilizing them in different areas.
Excellent. So you guys work for an educational organization. Is there a place, if someone wanted to do more than just listen to this excellent podcast or watch this video, to learn more about this, what are your recommendations? Let's give some hints of where people can pick up the thread and move ahead with this.
Well, we happen to have online with us here today the author of a very awesome heat pump book, Eugene Silberstein here writes a book on heat pumps. It is published by Cengage, carried by ESCO as well. We also have some online interactive heat pump software on our e-learning network, the HVAC Learning Network, that was recently released. It's a bunch of modules, a basic heat pump, introduction to heat pumps. If you want to take it a step further, a lot of the information in that interactive program came right from Eugene's book. It's phenomenal. I'll tell you, if you're really looking to dig into Eugene's book. We also have, again, if you're looking for the basics, we have another heat pump book at ESCO written by Randy and the team. Again, that'll give you a taste of it. So we do have some resources at ESCO. We have 2 titles that we carry. One is an ESCO title, one is a Cengage. And we also have an interactive intro to heat pumps as well.
Fantastic.
Not to give a shameless plug, but every year we run an education conference. And a lot of people think that our conference is only for teachers. But So we did change it. We now call it the HVAC Excellence National Education Conference, because we found that a lot of people who attend the conference are not on the front line of education, but they are in search of learning. So we run that conference every year. We've been running that conference since 2007. And our next conference is March 20th through the 22nd in Las Vegas, Nevada. And heat pumps. We have a few sessions at the conference that are geared toward heat pumps, as well as we have over 60 sessions on a variety of topics. A lot of them are geared toward teachers and how to deliver content, but a lot of them really appeal to contractors, technicians, people in the industry who need to learn more. And one of the neat things about the conference is that the sessions are created by industry professionals for industry professionals. I mean, Bill, you've been at the conference forever.
Right.
Bill exhibits at the conference. We have an exhibition hall where you can meet with the manufacturers of the equipment and tools that are out there to make your job as an industry professional easier. So shameless plug for the conference.
No,
Yeah.
great plug.
No, it's I just sidebar conversations with people that owners of contracting companies who are there to be stimulated with ideas to change what they do when they go back. I remember 1 hour long conversation I had with a local contractor from Pittsburgh, and he was there just eating it up and getting ideas on how to improve his business and exercising all the resources are there. So it's not a shameless plug. It's shameful if you don't go. That's
Exactly.
right.
There's another resource that goes along with it, kind of goes hand in hand with it. We've been working very extensively with the Department of Energy, assisting in creating modules and training materials that focuses on changes in technology. One particular is going to be our low ambient heat pump, cold climate heat pump technologies. And the Department of Energy will actually be a guest speaker at the conference. And starting in January, they're going to be a regular attendee on our Did You Know live show on Thursdays. So the Department of Energy is really reaching out to the industry to help promote education with these new technologies and how to use cold climate heat pumps more effectively.
That Did You Know show. Give me some
The
details.
ESCO Did You Know show.
Do you know anything about that?
Know a little bit about that. So just another avenue of us, working with our industry to help get education out as fast as we can. So every Thursday we have at 4:30 Eastern, we do a multi-stream live show. So we're on our HVAC Excellence LinkedIn, we're on ESCO Institute Facebook, YouTube, and then we're bringing in our industry professionals. So each week we grab a different industry professional, many of which are presenters at the conference, and to talk about things that are changing in our industry and just bring multiple levels of education of our industry, not just the technical side, but why things are changing. When you spend time with Jason going over refrigerants, go, wow, why is this changing? There are many reasons that it's changing. So we've been trying to bring in different professionals from different aspects of the industry.
Very good. So let's pick another myth to bust here. A1 refrigerants are non-flammable.
I can't comment on this one enough. I was doing a presentation at AHR. There was a lot of folks in the room. There were some contractors, technicians, people from all over our industry, sales, counter, just you name it. And one of the ideas that kept being thrown out there, or myths, if you will, that kept being, because I was talking about A2L refrigerants, is that why are we switching from non-flammable refrigerants to flammable? And I had to stop and correct them and say, they're not non-flammable. There's no flame propagation at a certain temperature. That doesn't mean they won't burn. In a house fire, whatever's in that air conditioner is going to be a good fuel. 410A, R22, 130, 134A burns pretty good if you get some humidity in there. I mean, it's really close. 410A is just R32, which is an A2L, with some flame suppressant R125 put in there till it got an A1 rating. So we can't throw the word non-flammable. If you put a torch to any refrigerant, it's going to burn. We'll say no flame propagation. And when the refrigerants are tested, they're tested at two temperatures, 60 and 100 degrees Celsius. And then when they ignite, they look at the flame arc and the characteristics of the flame and say, okay, this is going to get an A1 or this is going to get an A2L. A1 refrigerants don't exhibit combustion at those temperatures. A2L or A3 or A2 do. But they will ignite. I mean, there's plenty of videos, plenty of things. Again, in a good house fire, your windows, which are non-flammable, will start to burn. So we got to throw that out, that they're not non-flammable. It's just there's no flame propagation under a certain set of circumstances. Normal operating conditions, we'll call them.
So what does it take for you to know all this? What do you do in your time and / your spare time to be able to know this?
Well, I'm the director of industry standards and relations for ESCO. So I spend a lot of time in committees and AHRI committees as well. I'm a member of the SRTTF, which is the Safe Refrigerant Transition Task Force. I'm the chairman of one of the committees. And we we have all kinds of folks from the industry on with us, from manufacturers to labor groups to equipment. Everybody's on these groups. And again, it's voluntary, their own time. And they bring all of this information to us. And a lot of this stuff is hidden. If you actually sit down and read ASHRAE Standard 34, all of that information's in there. It's just very difficult to comprehend because it was written that way on purpose, to be, gray, if you will. But I read it and I decode it and I put it into, like Eugene said, 1-syllable words to bring out there to the folks so they understand what it means. To give you an idea, there's a refrigerant out there called ZE1234ZE. It's an HFO refrigerant. This is a little confusing, and it happens a lot in Europe, but this is the only refrigerant like it in the US. As far as ASHRAE is concerned, it is an A2L. However, when DOT does their flammable testing, they do it at one temperature. And if it doesn't ignite at that temperature, it doesn't exhibit the characteristics, they give it an A1 rating. So ZE is one of those refrigerants where ASHRAE, AHR, we call it an A2L when it's in a system, but when it's in transit, it's an A1.
Oh. So just to make sure people are listening, comprehend some of the acronyms you used, can you break down A1, A2, A3, just somewhat? I know there's great graphics on it you guys have got. So
the number is the level of flammability, 1 being the lowest and 3 being the highest. And there's 4 divisions, 1, 2L, 2, and 3. So when you think of 1, think of 410A or 134A or 404A. And when you think of 3, think of propane or isobutane. These are our A3s, highly flammable. And in the middle, there's a 2 category that's subdivided into 2 and 2L, 2L being the lower. A lot of the refrigerants that we're transitioning to are R32, R454B, the new HFOs, the ones in our car, 1234YF and 1234ZE, which we're going to see in chillers, are 2Ls. The lower the GWP, as we start to bring it down, the higher the flammability starts to go, especially true with hydrocarbons. And then the letter, obviously, is toxicity, A or B. A lot of folks don't know this. Ammonia. When you think of ammonia, you think, oh, that's toxic stuff if I breathe that in. But it's flammable as well. Ammonia is a 2L refrigerant. It's just toxic before it becomes flammable. When we start talking about these refrigerants, it's what hazard becomes acute first. And with ammonia, it's the toxicity. But it is also a 2L refrigerant. It is flammable in the right mixture.
Got it. Okay, let's bring forth another one. R32 is a suitable replacement for our 410A. Jason raises his
hand. Keep on going, Jason.
No, I was going to defer to one of the other gentlemen before I can get this for days.
Yeah.
As we mentioned earlier, 32 is part of 410, but it's only half of it. The pressures and temperatures are similar. However, 410A is an A1 and R32 is an A2L. R32 is SNAP approved, which means it's allowed for use in certain applications. However, those applications are for new equipment only. And this is equipment that has the safety mitigations built in to deal or mitigate any risk of ignition. These A1 systems don't have any of that stuff in it. We have a contactor, compressor, capacitor, condenser fan motor. All the electrical connections are either wire caps or, the stake-ons, and there's no protection, if you will. In these newer systems, we're going to have refrigerant detection systems in most cases. We're going to have intrinsically safe electrical components. They might move some of the components around to get away from refrigerant lines and things, but R32, R454B, any of these A2Ls are only for use in new equipment designed to mitigate that flammability risk. We can't backwards go into A1 systems, and likewise, we're not going to go with an A1 refrigerant and an A2L system.
Okay. And these safety mitigation systems, that's can you get a little bit further into that?
So think furnace, all right?
Okay.
We have natural gas, which is an A3 if you want to get to it, and we bring it into our house and we set it on fire. And that's how we stay warm up here in the north, all right? We bring this highly flammable stuff in our house and we set it on fire. And why aren't we worried about that? Well, there's all of these safety switches built into the furnace, to each one with a different purpose: a rollout switch, a limit switch, a pressure switch, an auxiliary limit switch. And they're all designed to detect a different safety hazard. These systems are going to have refrigerant detection leak sensors, if you will, again, based on charge size. Not all the smaller systems like window units don't require it because there's just not enough refrigerant in there to achieve combustion. Think of a rollout switch. What happens when a rollout switch opens? We shut the burners off, we go into lockout, and we turn the blower motor on. Something similar to that, where if one of the sensors, one outdoor at the condenser, one indoor at the evaporator, pick up a leak, they're going to shut the system down and turn the fan on. And that air movement is going to be enough to disrupt and bring the mixture below LFL so we don't achieve ignition. In larger systems, we may see an automatic pump down where if it picks up a leak, it pumps all the refrigerant to an outdoor condenser and seals it out there. And again, puts it in lockout. These sensors are designed to look like every 15 seconds for a leak. So topping off isn't going to work. If you come up to a system that's in lockout with an E2L and you top it off, that sensor in 15 seconds is going to sniff that leak that you didn't fix and shut the system right back down again. You're going to have to fix that leak.
Got it. And you talked a little bit about combustion systems. Can I ask you to shamelessly plug another
Which
publication?
one? The gas heat book?
Yes.
It was developed by ESCO, the ESCO group. I was the lead author, but the entire team gave me input on it because, again, we have team members all over the country and they all experience combustion in different ways, north, south, east, and west. It's a really good book, in my opinion, if you will, shameless plug, but there is a gas heating book, 11 chapters that covers furnaces, boilers, combustion, installation service, all kinds of stuff. And it's, again, and then there's an e-learning course for it on the HVAC Learning Network as well.
So to satisfy more educational hunger there. Clifton or Eugene want to respond to R32 as a replacement for 410?
I think Jason kind of summed it up really well.
Yeah.
There was a comment brought up in the AHR session I did where the contractor asked, well, since R32 is half of 410A, can I just use half the charge?
Oh,
you're right.
Wow.
And again, I had to say, well, listen, this equipment's going to be labeled. There's going to be safeties built in.
Very specific.
Right. You can't go back and forth with this. We're not the chemists. We're not the refrigerant manufacturers. We're not making our own blends. Blends are created in the lab by an engineer or a chemist, not in the field by technicians.
That's right.
And I think it's important to say that although R32 might be air quote new to us in Europe, it's been used for a very long time. And I have
Thank you, Eugene.
who live
Absolutely.
in Europe. And it's funny because, I think Clifton, you have colleagues over in Europe as well. Yeah. And it's funny because they're like, oh, well, you're finally using R32.
Yeah.
So a lot of people in the industry think it's new, but it's something that's been around for so long.
Yeah.
But
When we were transitioning
about the, about R32 being 50% of 410A. But again, at the conference, we have people from the refrigerant manufacturers. I mean, Jason's there. There were a lot of sessions and roundtable discussions where people can bring their A2L questions and get them answered. Because I think one of the problems that we're encountering, and Bill, you're bringing up these myths, it's really about education, and it's impossible for everybody to know everything. But I think what is important is knowing where to get the information. So I don't, having the answer is great, but if you don't have the answer, but you know who to turn to get the answer, that's great. Because, a lot of people in the industry, if I don't know something, I'll just make it up.
Yeah.
And nowadays making things up is very, very dangerous.
There's a lot of room for that too.
And we've mentioned a couple times the AHR Expo, the Air Conditioning, Heating, Refrigeration Expo happens annually. This coming year, it's going to be in early February in Atlanta, Georgia. If you go to AHR Expo, just search for it. You'll find out admission is free, and there are many sessions that you can attend that are free of charge. In addition, you get to meet with the manufacturers. If any of this sort of tickles your fancy, that's a great place.
That's the place to be.
Get exposed to more. So, all right. So another myth to bust here: SEER2. Where did it come from? This took us from surprise. I mean, I open up the news and it's talking about SEER2. Where'd that come from?
2016.
Isn't that crazy?
What?
Yes,
Clifton, it's
absolutely.
funny. It's funny because I know Clifton has a lot to say about this, but I just went to a school to speak to the students about CO2, and the teacher said, "Well, why all of a sudden? What's up with this?" And it's really, really funny because I was like, "Well, CO2 was introduced in 2016." And I said, that would be like walking into an event with your 7-year-old son, hand in hand, and say, "Oh, here's my newborn baby."
Yeah.
The kid's in second grade. So CO2's been around. CO2 is a second grader already. It's actually kind of funny.
Yeah.
So where do these things get shared? Maybe somebody just missed out on it, missed out on the announcement. Why do you think they might have missed it?
So now we're talking about Department of Energy changes, right? So Department of Energy initiated our SEER2 analysis in 2016 because the realization that we've been using SEER1, which you'll hear it called sometimes, or just SEER. We established SEER ratings in 1987 with the assumption that all air conditioners ran approximately the same, no matter where they were in the country. And so we kind of stuck with those standards. And then as we started realizing, especially with changes in equipment, inverter technology and variable capacities, there had to be some better understandings. We had different usages, different zones. And so in 2016, we established the fundamentals for what would become SEER2 ratings. And I think that we've not really concluded it, but we see that there was a misconception that SEER2 education would come through the manufacturers because they were the ones making the most significant changes in the equipment. And I think as we look at an industry and realize that those are significant changes to be done, and not everyone implemented those changes in 2016, 2017. They were getting towards the end of the cycle before the changes in equipment were going to happen. And that's really what we've seen. So we know that SEER2 equipment is already in manufacturing and has been since midsummer in most manufacturers. And that equipment that is being sold is, we're getting ready to stock up on SEER2 equipment. So I think the realization is that there wasn't any formal training on SEER2 changes to the contractor level. And so that often happens in our industry. So there's all these different pieces of the industry. They all have the right design. They all have the best interest of the industry. But sometimes in the process, it's not clarified who is providing the education on that. And I think that was what happened, is that path wasn't completely clear. I think it'll be a lot more clear by the manufacturers when they start releasing equipment, because they're going to want technicians and contractors to understand what those changes are. But the prelude to those wasn't carried out very well. And that's why you see me out there with my bell. the SEER2 apocalypse is coming, because unfortunately that pre-education, that prelude of education for SEER2 didn't really happen. Now, there are some sites out there, primarily equipment distributors I've seen doing most of the SEER2 preparation and education. So we'll start seeing more of that. We've had one manufacturer come on the show and talk about the specific changes that they will be doing. Most manufacturers have not released even to their own contractors exactly what those changes look like yet. So they're trickling through, but they're going to flow in a few months.
So just again, to cater to any listeners that might not be familiar, the acronym SEER, Seasonal Energy Efficiency Rating. So it was the process by which the rating was achieved has shifted to a different process for the manufacturers to conduct.
The M1 ratings. And you'll hear a lot about M1, and that's the standard that we're using for the actual testing of equipment. So it's the standardization process.
Can you speak towards how the testing has changed?
Not very fluidly.
Okay.
It was a lot in the static pressure.
It is very much static pressure.
Yeah, it's really,
go ahead, Eugene.
I'm sorry, Jason. The
ahead.
goal is really to better represent how the equipment is going to function when it's installed.
In real world scenario.
One of the misconceptions was, it's a misconception within a misconception, is that all duct systems, all air distribution systems are installed and designed perfectly. SEER 1 was relying on, Jason, what, zero point 0.1 static?
Yes.
Point two.
Point
Huh?
1, point 2,
Yeah.
depending on the
So
application. Yeah.
unfortunately, residential systems that were installed, it was grab a 4-foot plenum, screw it on to the outlet of the air handler, and then go up into the attic with 16 boxes of flex duct and have at it. So SEER 2 is really trying to create a more accurate representation of how that system is going to perform once it's installed. So the
0.5.
static pressure now is about 0.5 for SEER 2. So just to give a little more accurate representation of what the system is doing. So the SEER 2 ratings are actually going to be lower than the SEER 1 ratings by about 5%. So just to get an idea, if you have a system with a SEER rating of 15 and you multiply that by 0.95 or 0.96, that's going to give you an approximation of what the SEER 2 number would look like to convert. Because think about it, static pressure is really the resistance to airflow in the duct system. So now if you have an inverter controlled blower, as the static pressure increases, that blower is going to have to work harder to overcome that static. So there's going to be more energy used per BTU per hour. So the efficiency of that system is going to drop. So the new SEER 2 numbers are going to be slightly lower than the SEER numbers. And again, there are 3 different regions in the country. So there's a northern region, there's a southeast and southwest, and the rules are slightly different, for each of those regions.
For the acceptable equipment to be installed in those regions.
And Bill, it's not always install. All right. In some regions, it's date of manufacture. So in the north, we go by date of manufacture. So if it's manufactured before January 1, 2023, then it can be installed whenever. But in the southeast and the southwest, it's installation date. So if a piece of equipment is manufactured but cannot be installed in California, Florida, Texas, Oklahoma, anywhere, and it can't be installed by January 1, 2023, then that equipment needs to be shipped to the north where it can be installed whenever. So there are regional differences as far as SEER levels, SEER 2 levels, HSPF, rated heating season performance factors for heat pumps. So there are 3 distinct regions in the country, and the rules are slightly different in all 3.
But it's the rating of the equipment. The equipment could be the same, identical equipment. It'll just have a different rating to it. Is that true?
Could. But what we've seen is a pretty significant change in manufacturing of equipment. So with our one particular manufacturer, when we were looking at equipment that will be utilized, they were actually already making preparations for A2L designs that will be coming here in another short period of time. Mm-hmm. So a lot of systems that we are comfortable with now, like single stage compressors, are going to be far and fewer in between. We're going to see a lot more inverter technology and multi-staged equipment in just a few weeks.
But to hop on your point, so the SEER 2 requirements are different in, let's say, the northern region and the southern regions. So potentially there is a piece of equipment, if it had a SEER 2 rating of 13.4 and was a split air conditioning system, you could install it in the north, but the minimum SEER 2 requirements in the southeast and southwest are 14.3. So you can have the same piece of equipment, and depending on where you drop it in the country, it may or may not be allowed to be installed.
Okay. And because of the focus on southeast and southwest, we're going to say this is to address electrical consumption for air conditioning?
Yes,
is that
correct.
the motivation behind this?
Yes.
Okay.
If you dig into SEER 2, you'll also find some minor things about standby losses as well with inverter boards and things that are constantly running when
constantly utilizing wattage.
When the system isn't running, but the inverter boards are running. So there's some stipulations in there about standby losses for heat pumps and air conditioners as well. But the big change was static pressure, the M1 testing standard.
Got it. Okay. All right. Reclaim refrigerant. It's garbage. It has no value, right?
You just spouted out what a lot of technicians believe or don't know.
Okay. How are we going to bust this myth?
Recovered refrigerant does have a lot of value, and we're in a phase down. We are in an HFC phase down. Just to point to a question, so how come nobody knows about this, this SEER 2 or the A2L transition? Well, when it's announced, people look, their immediate focus is the date. Oh, I'll worry about that later.
Right,
I have this installed. I have to
I have
do
time
this.
left.
I have, and then all of a sudden it creeps up on you, and you're like, where'd this SEER 2 thing come from? Remember the thing you read a while back? Yeah, it's here now. The common thought was that if the refrigerant is mixed, they're going to charge you to get rid of it. It's not worth anything. It's garbage. And that's just the technology is evolved to where if we bring in a refrigerant, they can clean it up. They can bring it back to the standard, new product standard, and sell it. And they're with the shortage of refrigerants with a phase down, they're willing to pay for that.
Okay.
So that refrigerant does have value.
How could someone capture that value? Where do they go if either they want to learn more or they actually have refrigerant that's been reclaimed?
Sure. We actually just did an interview with Kate Horton from Hudson Technologies talking about recovery of refrigerants. And what a lot of people don't realize is that we are in this HFC phase down. It started in 2022. So a lot of people ask, well, why did R410A prices go up this year? Well, because we stopped manufacturing it by 10% in 2022, all HFCs. And in 2024, we're going to add an additional 30% reduction to that. So that it'll be 40% less virgin refrigerant available than what there was in 2021. So in the past, it hasn't been a push to recover refrigerant as much because the supply was available. And so what we're seeing is that a lot of the calculations that determined this HFC phase down were based on, thinking that a significant amount of refrigerant was recovered from the field and reclaimed back into new refrigerant. And unfortunately, what's been realized in that is that number is significantly lower than expected. So as these new virgin HFC refrigerant supplies diminish, the demand for our HFC refrigerants are going to increase. And if we don't recycle properly, and if we don't reclaim refrigerant, we're going to add to the shortage of supplies of refrigerants. So in the past, where we've had refrigerant and we turned it in for exchange, it didn't have a lot of physical value because the cost of manufacturing was low. Now we're going to see a cost of manufacturing and supply being much higher, which means the supply that we provide has a significant value. So going forward, the price of reclaimed refrigerant is going to increase significantly for HFC refrigerants particularly. Those will be the ones that are really impacted the most. Kind of goes back to when we're talking about R32. A lot of people don't realize that, like Eugene said, most of the world started adapting R32 in 96, 97 when we started adapting R410A. And as we talk about HFCs, one of those misconceptions that can happen when we look at our list of refrigerants that are being phased down, right? We don't see R410A particularly on that EPA list. But we do see R32 and R125 because a lot of people didn't realize that R32 and 125 was 410A. So 410A is absolutely on that phase down, as well as R32 and any blends that use HFC refrigerants, including some refrigerants that we're going to be seeing in this next year or two. So the supply of HFC virgin refrigerants are going to diminish by 85% over this phase down. 10% in 2022, 30% additional in 2024. And then we're going to do some additional phases over the next decade or so. So the importance of recovering and reclaiming has never been more valid than it is right now. So now we can look at our refrigerants, because in the past, we didn't make it a priority because it didn't have value. You just put it in a jug and you put it in the shop and it just sat there. Well, now going forward, we'll actually have value on that refrigerant. And I would guess that a significant value after, say, like 2024.
We talked a lot about refrigerants so far. I mean, that seems to be that's a hot topic for myths that need to be busted. Here's another one I'm going to throw in there. This is one of the ones you suggested. Equipment brands. I mean, what's on the label? That determines the quality, performance, and longevity of service. I mean, there are certain brands that just perform better, right?
That's definitely a big myth.
Yeah.
And I think all four of us touched on this at some point today, because if we employ best practices, if we evaluate the space, Jason mentioned looking at the structure, is it compatible for a heat pump? If we're doing proper heat gain and heat loss calculations, if we're sizing the equipment correctly, if we're utilizing best practices to install the equipment, to leak check, to evacuate, to charge according to manufacturer specs, if we properly design and execute our air distribution systems, our duct systems, then once the system's put into service, there's no reason it should not function. So it really boils down to the technicians. I mean, equipment will function. Every manufacturer has their nuances, their little idiosyncrasies, their trade secrets, their secret sauces. Mm-hmm. But a system should operate well if best practices are employed. Unfortunately, if a customer is experiencing a system that's not working, they'll go out and look at the unit and they'll look at the nameplate and go, oh, that piece of equipment, that manufacturer is substandard, or oh, it's not a good manufacturer. Jason, I'm gonna blow your horn right. Jason has this expression, and he says, all equipment is created equal, and then it's installed. And whenever he says that, I have to chuckle, because it is so true. You have people out there who still don't evacuate equipment, and they're not properly leak checking, and all arrows point back for the most part to the people who are installing and sizing and getting this equipment installed. So I think it has less to do with the brand or the nameplate that's on the equipment, and more so with the people who are installing. And a lot of manufacturers realize that, and some of them have their manufacturer specific training.
Yeah,
that say, okay.
I was just going to ask about that. Is the manufacturer training, is that sort of a defensive posture to this situation? And without naming names, but do you think there's a variation in the amount of manufacturers training provided, and perhaps that's where the association with the nameplate comes?
I think they're all starting to get on board with the manufacturer training. You're starting to see more and more of them pop up in the different, especially as these changes are coming out, the SEER2 and the A2L transition. You're starting to see a lot more manufacturer training. They understand that the contractor, the technician, is the front line for their unit with their name on it in the customer's home. And in the end, it's their name on the line. So they want to make sure that the people that are accessing this equipment are doing the right things with it, so that they don't get a bad name. I'd like to point out that when you said some equipment is better than others, they're all tested to the same standards. They all have to achieve the same standards in the SEER testing, the UL testing for safety,
ISO
all of the
ratings.
standards, right? So if a piece of equipment is put on the market, it has met all of the minimum or maximum standards necessary to be on the market. So when we throw that expression out there, all equipment is manufactured the same and then it's installed, they are all tested to those same standards.
Got it.
Well, Bill, let me ask you a question.
Sure.
When you bring your car for service, right? Don't you bring it? Well, not everybody, but it is strongly recommended that you bring your car to the company who manufactured your vehicle. Every car manufacturer has, yes, you have certain auto mechanics that'll work on every car, no matter. I've always brought my cars back to the manufacturer for their service, because who's going to do their service better than them? Who has access to the most up-to-date manuals and access to parts as readily as the manufacturer? So every air conditioning manufacturing company, their job is the same: to provide comfort, cooling, comfort, heating, to provide comfort. But their controls, their troubleshooting techniques, their error codes, they're all different from manufacturer to manufacturer. So I think it definitely behooves them to conduct manufacturer training. Some manufacturers even say, well, you will be an authorized technician through our company, but you need to get recertified every 2 years or every 3 years just to make certain that you're up to date.
Mm-hmm.
So I think it really is important, because you don't want somebody who's not trained on your equipment servicing your equipment.
Yeah. So I think we covered a lot here. We could cover more. We should do this again.
Love to.
But I'm going to throw a sort of a tongue-in-cheek line out there and just see your reactions individually. This is all going to settle down in 2024, right? I mean, 2023 is just going to be year change. And wait, you're laughing at me. Why are you laughing at me?
Well,
Wow.
there's some more rulings. The AIM Act that we've thrown out there, which is what started the HFC phase down, requires 3 different rulings. One is out. It established the timeline, the phase down, what the percentages are. And there's 2 more rulings that are due. There's a bunch of petitions in front of the EPA for a bunch of different things. There's a new proposed rule this morning that's being put out there. So until all of the transition is finished over the next, say, decade, we have more rulings coming down out of this AIM Act. And again, the AIM Act was something that wasn't started by the EPA. It actually passed through Congress, passed through the Senate, bipartisan, was signed by the president at the time. So, I mean, this is something that can't be undone by just a wave of a pen. It would have to be repealed through Congress, through the Senate, through the president. It's just not going to happen. So again, this started at the highest levels and rolled its way down to us.
Yeah, but Jason, I think it's important also that a lot of people look at the changes that are coming with equipment, with refrigerant, and a lot of people say, oh, well, this is just a cash grab by the equipment manufacturers. They're doing this. The refrigerant manufacturers, they're doing this just so we have to buy new stuff. We have to buy new testing equipment. We have to change the equipment we're using. And a lot of these changes were brought about by the industry itself. Correct. Again, like with the CO2, we mentioned that we wanted the equipment to actually mirror its performance once it's installed. So these are really adjustments and advances that we're making to better the industry. And I don't think it's fair to say that it's a cash grab by the refrigerant manufacturers or the equipment refrigeration manufacturers or the organizations in the industry.
I just pulled up a reference here from Opteon on the American Innovation and Manufacturing Act, the AIM Act, and it talks about 3 major things it's expected to bring, which is new jobs, 33,000 new jobs, almost 39 billion in direct and indirect manufacturing output, and 12.5 billion improving the U.S. trade balance in equipment and chemicals. So it's a reaction by Congress to what's happening in the rest of the world to keep American industry competitive.
Right, we're making HFCs and nobody else can use them. So where do we ship them?
Right. Yeah. So so it's a fallout kind of thing, but it's being done with I'd say the bigger picture in mind, and it's all going to impact us.
Absolutely, it will.
Fire suppressants, foam blowing agents, propellants, solvents, automotive, refrigeration, and HVAC. It's hitting us everywhere. All these
a lot of people think that it's just HVAC, but there are so many other industries.
We're a small piece of it.
Yeah, we are.
Right.
Total AIM Act is $369 billion of overall education infrastructure redesign. And when we think about our portion of that and go 4, we're a small piece of the initiative, and it's a global initiative. So many of the things are, part of international treaties. So many things affected by the EPA come from, like the Kigali Amendment to the Montreal Protocol. It's things that we're not going to be backing out easily. So this is, I guess, it was initiating a political question. Will things change when politics change? Well, we all know that some things can, absolutely.
You sensed how I snuck that in there, huh?
Will some of these big things change? No, especially things like refrigerant phase downs. Those are here to stay.
Got it.
CO2 is here to stay.
CO2 is here to stay.
Yeah. The expansion of cold climate heat pumps is happening. You're not going to stop it.
We've already seen many jurisdictions, local jurisdictions, that are banning, new gas connections and requiring cold climate heat pump technology. So those are not federal initiatives. Those are local and state initiatives that are going to direct, like I said, that are directing the changes in the manufacturing. So they're not starting from the top. They're literally starting from the lower levels of the industry and working their way back up the chain.
Yeah, there are areas in my neck of the woods where you cannot install new natural gas systems.
Right. Yep. Many places around the country starting that
Absolutely.
initiative.
Actually, I had a student ask me when I was out of school last week, oh, well, we have SEER, now we have SEER 2, when are the next changes coming? And that's what I mentioned. Well, SEER, as Clifton mentioned, was introduced in 87, and SEER 2 is 2016. So you're looking at 30 years. So by the time we're looking at SEER 3,
right,
I think I will be a little
On a beach
grayer.
somewhere.
I have hair at all.
Yeah.
So it takes time. These things don't happen overnight.
But to sum it all up, the resources are there. Clifton, Eugene, Jason, great resources, great approachable people that were either married, born, or abducted into the HVAC industry. I'm going to keep using that, Jason.
Oh my gosh. I'm thinking that's like a profile highlight.
So thanks again for coming on this podcast and both the video and audio portions of it. I look forward to seeing you all in person, and I hope some of the listeners here either are going to see you at the AHR Expo in Atlanta or see you in Las Vegas at the National HVAC Educator and Trainers Conference in March. I'll put links to all this, some of the things we talked about, especially the conferences and the resources. And if you're okay, can I share your email addresses?
Oh, yes, please do. Contact information.
Those will be in the show notes. Yeah. All right. Perfect. Well, thanks again for coming on Building HVAC Science podcast again today.
Thanks for having us.
Thank you so much, Bill, and everything you do.
Thank you.